Alright, I'm going to do January 2017, parts 2, 3, 4. In attempting to solve the system of equations, y equals 3x minus 2 and 6x minus 2y equals 4, John graphed the two equations on his graphing calculator. Because he saw only one line, John wrote that the answer to the system is the empty set. Is he correct? The empty set means that they don't cross, there's no solutions that match, so if he's only seeing one line, he's thinking that there's no points of intersection. Points of intersection are essentially solutions to systems. For example, if you have a picture that looks like this, two equations are called a system of equations, and they cross at their solution. So he's imagining that if he's only seeing one line, that there's no place where they cross. But here's the problem. This would make a whole lot more sense if the second equation was solved for y. To get y by itself, I'm going to subtract 6x. And then I'm going to divide by -2. And what you're going to see happening, -6 divided by -2 is 3x minus 2. He only saw one line because he only has one line. They're the exact same thing, just written in a different way. So is he right by saying the empty set? And the answer is no. There are infinite solutions because the lines are the same. Okay? Question number 26. A typical marathon is 26.2 miles. Alan averages 12 kilometers per hour when running in marathons. Determine how long it would take Alan to complete a marathon to the nearest tenth of an hour. Okay. How long? Well, there's a formula that says D equals RT. It's called the DIRT formula. And you could easily figure this out just by knowing what R stands for. R is your rate. So if you're driving miles per hour, it would be like saying D divided by T. It's this formula. We're going to plug in what we know. We know that his distance is 26.2 miles. We know his rate is 12 kilometers per hour. Okay, we've got a problem here. Kilometers per hour. And the question is how long? So T is invisible. Here's the problem. You can't have miles and kilometers in the same problem. They have to be the same type of unit. So if you go to your first page here, back of the first page, there are conversions on the front, or on the back side of it. And I'm looking for, right here, 1 kilometer is equal to 0.62 miles. Okay? That means that 12 kilometers times 0.62 would come out to be, let's see here, 12 times 0.62 is 7.44. So here's what this really says. 26.2 on the left equals 7.44 times t. If I want to get t by itself, divide both sides by 7.44. 26.2 divided by 7.44 is equivalent to this massive number, or it's extended. It says to the nearest tenth of an hour, though. So here's what I'm going to write. Right now it says 3.521505376. Your tenths place is one number after the decimal point. Because that 2 follows it, that means I don't have to round up to compensate. If it was a 5 or more, I would have to round up. So the final answer is approximately 3.5 hours. Okay? Question number 27, solve the inequality. I told you in class that solving inequalities is very similar to solving equations, and I'm going to hold to that. My first step, though, is to always move the variable first. So I'm going to bring the variable to the right. I'm going to add 2y I still have 1.8, but now I have plus 1.6y. And now I'm going to get rid of the 1.8 because it's on the side with the y and it shouldn't be. This becomes 0.4. If I divide both sides by 1.6, which is the coefficient to the y, keeping this symbol the same every time, unless I divide it by a negative at the end, or multiplied by a negative, 0.4, just so you believe me that it is 0.4, 2.2 minus 1.8 is 0.4, and then 0.4 divided by 1.6 is 0.25. There's your solved inequality. Okay. Moving on. Give me a second here, I have to stretch my back. Alright, the question is, Jacob's working on his math homework. He decides the sum of the expression must be rational because it is a fraction. Well, if it was rational, then we would have a rational number as an answer when we plug it in. But look what happens. If I take 1/3, which is a rational number, plus the next fraction, which is 6 root 5 over 7, we get a really nasty decimal. Well, here's the thing. Root 5 is irrational. And the truth is, any sum with an irrational number is still irrational. It doesn't matter what we add to it, okay? If we add a nice rational number, it's not going to change the irrationality of what's already there. It's just going to move us up a little bit further into that same type of irrational number with its decimals that are going on forever and ever and ever. To clarify what irrational means, it means it does not end. Okay, this decimal is just a short portion of what this number actually is. It goes on forever. And it does not repeat. Again, if you look at that number, there's no repetition that we see. You see 2 9s in a row, but when it says repeat, it's talking about repeated decimals like 0.555555555. Even if that number showed up later on, like 0.555, you know, down here, that's okay. It's still a repeated decimal, but it's not enough for a repeated decimal. If the question says anything about the word rational or irrational, I want to see these two words, end and repeat, as part of your answer. If it's rational, then it either does end and repeat or something along those lines. We'll talk about rational a little bit later. But if it's irrational, this is exactly what I want to see. Does not end, does not repeat. Okay? Technically, a rational number is a number that can be written as a fraction with integer, numerator, and denominator. We'll talk about that again, like I said, later. We have not graphed inequalities yet, so here's how you would do that. I'm going to encourage you to always, always, always have a table when you're doing your inequalities or your equations. So we're used to that. I'm going to type it in as if it was an equation. So y equals 2x minus 5. And I'm going to copy my window, maybe a couple negatives, and a few positives. So -3, -11, -2, -9, -1, -7, 0, -5, 1, -3, 2, -1, 3, 1. And I'm going to follow the pattern after that because there's no list of what my intervals should be, so I'm just going to do this as is. It's been really helpful to us to label our x-axis first, so I'm going to do that. If you don't want to do that, it's fine. I don't normally, but I feel like, again, it's been helpful to us. So at -3, I'm going to go down 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ran out of room, so I'm not going to use that point. At negative 2, again, that was negative 10, so negative 9 is right here. At negative 1, I'm going to go down 7, which is 2 less than before. I'm going to go down to negative 5 on 0. At 1, I'm going to go down negative 3. At 2, I'm going to go down 1. At 3, I'm going to go up 1. Do you see the pattern here? Okay, it looks like every time we're going up 2 boxes over, up 2 boxes over 1, up 2 boxes over 1. Keep that up 2 boxes over 1. Okay? Now here's a couple things to know when you have an inequality graph. If you have either one of these, then your graph is going to be dotted. If you have either one of these, then it's going to become solid. Solid graphs are like your equations, right? You would just connect the line, and since they have the equal sign in them, that's why they look like regular equations. But because this one doesn't have the equal sign underneath, it is a dotted line all the way down. Okay, label it. There's one more piece to the puzzle, and that's shading. Okay? In order for something to be shaded, you need to see whether or not it works or it doesn't work, because in an inequality, it's not just the equation or the inequality that could or could not be the answer. It's the whole side that it's splitting. So if this is the river, I want to figure out what side of the river has the answers. One of the sides does, but not both. So to figure that out, I pick a point, and usually I pick 0, 0 unless there's another, unless that's covered. You don't want to pick a point that's on it, okay? So I'm picking 0, 0. And I'm going to store 0 into x and 0 into y. If 0, 0 works, then I'm expecting the calculator to tell me 1. If it doesn't work, I'm expecting the calculator to tell me 0. So I typed in my inequality, 0, 0 works. If this works, then it's on the side that does work. Think of this as the line where, maybe there's a war going on, and this is the team that's battling this team, or the country that's battling this country. Since 0, 0 is in the country that did work, then all of that side worked. They worked together. So we shade it like that. Okay? Moving on. Sandy programmed a website checkout process with an equation to calculate the amount customers will be charged when they download songs. The website offers a discount if one song is bought at the full price, and each additional song is 99 cents. So keep in mind, when you see each, this is referring to the slope, and when you see that something's happening just once, this is the y-intercept. We haven't talked about this in length, but know that all linear equations are of the form y equals mx plus b. M is your slope, and b is your y-intercept. We've worked with m already when we were calculating slope, average rate of change, but here we go. It says state an equation that represents the cost C when S songs are downloaded. Because C is capitalized, and for other reasons as well, C is the y value in this question. So I'm going to write C equals. S is the variable that we're going to use in place of x. Now what's the slope? Slope was 99 cents. And your y-intercept is the number we're adding at the back end, 1.29. You have to use the right variables. Sandy figured she would be charged, here's your C value, at $52.77 for 52 songs. Is that correct? Basically they're saying, could 52.77 and 52 work out as a solution? So you can either show this by algebra. It doesn't say algebra. Same with this one. It doesn't say check algebra. By the way, it did say state the coordinates of a point in the solution. We did that already, 0, 0. If it said algebraically, we would have to plug it in by hand, but since it doesn't, I'm going to take 52.77 and store it into C, and I'm going to take 52 and store it into S, and then see what the calculator says. 52.77 stored into the letter C, and 52 stored into the letter S, and then is C equivalent to 0.99 S plus 1.29. And the answer, this says 1. We know that 1, so calculator says 1, which means yes, it is a correct amount. Okay? A family is traveling from their home to a vacation resort hotel. Its table below shows their distance from home as a function of time. Determine the average rate of change between 2 and 7. Average rate of change was y2 minus y1 over x2 minus x1. It is not given to you. So here are the 2 points we're looking at. 2, 140 and 7, 480. Label them. This is the first x, the first y, the second x, the second y. 480 minus 140 over 7 minus 2. Throw that into the calculator exactly how you see it using the fraction option. And you get 68. You need to put a label on average rate of change questions. So 68, x's over y's, hours, whoops, I did that wrong, sorry, y's over x's, miles per hour. Okay. Nora says that the graph of a circle is a function because she can trace the whole graph without picking up her pencil. Mia says that a circle is not a function because multiple values of x map to the same y. Determine if either of them are correct. So, is that a function? And the answer is no. So I'm going to say Nora is wrong. Circles don't pass the vertical line test, right? It crosses in more than one spot. So Mia was saying a couple examples where multiple x values, like 1 and 2, go to the same y. That's not the problem. It's when x's repeat that it's a problem. So Mia is wrong. Functions can't have repeating x's, not y's. Okay? Moving on. Graph f of x equals the absolute value of x. We talked about this in the last lesson, so just as a reminder, again, I don't expect you to graph anything on your own, just use the table given to you. Go to y, and the absolute value is the first thing in the catalog. Remember, blue 0 is the catalog, first thing there. I'm going to put an x in there. And I'm going to graph this one first. Copy down a table of values. -3, -2, -1, 0, 1, 2, 3. 3, 2, 1, 0, and then it comes back up, 1, 2, 3. Alright, so what does that look like on paper? Well, normally I would have the ruler with me, so I apologize. Use a straight edge, use the side of a piece of paper or something for yourself. Label your y. My x somewhere in the middle. For that as well. And because we're used to labeling our number line, we might as well continue to do that. Okay. At -3, I go up 3. At -2, I go up 2. At -1, I go up 1, 0, 0. And the graph looks like this. Extend the legs of the graph. In fact, it would benefit you to put the entire table down so that you're certain about the points that fit on this graph. That's f of x. Okay. G of x is going to be its own set of values. So I'm going to type that one in now. -x squared plus 6. Copy the table. At -3, it's 3. Sorry, at -3, it's -3. At -2, it's 2. At -1, it's 5. At 0, it's 6. At 1, it's 5. At 2, it's 2. At 3, it's -3. This is a parabola. Remember we talked about how equations that have 2's in the exponent are quadratics, and their picture is a parabola. So this one is a quadratic because of the 2, and this one is an absolute value because of the symbol there. Okay, absolute values look like B's, quadratics look like U's. Does f of -2, which would be the value at -2, here's -2, f and g both cross? So are they equal at that point? And the answer is yes. Okay, point of intersection. The answer to both of them is +2. Two friends went to a restaurant and ordered 1 plain pizza and 2 sodas. Okay, so the system of equations is going to be based out of the variables and stuff that they use. They don't have variables stated, so we're going to be creative with ours. We have pizza and soda. 1 pizza and 2 sodas are $15.95. Later that day, 5 friends went to the same restaurant. They ordered 3 pizzas, and each person had a soda. There were 5 of them. 5 sodas for $45.90. There's the system of equations that's going to get you at least 1 or 2 points on this 4-point question. Okay? Now what do we do with it? It says write and solve. Solving a system of equations requires something to match. Now what do I mean by that? I mean either your P's have to match or your S's have to match. So just for consistency and the fact that we're not going to be in school for a significant amount of time, I'm going to just be like every single time I'm going to make my P's match or make my first letter match. They don't yet. So how can I make 1 look like 3? Well, if I multiply it by 3, it will, right? Okay, so what does this look like if I multiply everything by 3? I get 3p, I get 6s, and I get 1595 times 3, I get 4785. The next line is 3p, 5s, and 4590. I haven't changed anything to that one. Now, they match. I don't really want them to match, though. I want them to be opposites. So I'm going to change every sign in my second equation. It only works if we change all of them. If any of them were negatives, they would become positives. And then here's what we're going to do. We're going to answer 3 different addition problems or subtraction problems. 3 minus 3, or 3p minus 3p cancel. They're the same. 6s minus 5s is 1s. And 4785 minus 4590 is $1.95. So here's what I know. It says to determine the price of 1 plain pizza. I didn't find pizza, I found soda, right? This is why the variable s is important, because it tells me what I solved for. It's $1.95 for a soda. To figure out pizza, you have to plug it into one of these equations and figure it out. So I'm going to go back to that first equation. It said 1 pizza plus 2 sodas are equal to $15.95. 2 times $1.95 is $3.90. I'll just write 3.9. To get the p by itself, I have to subtract 3.9 from both sides. And then one pizza is equal to $15.95 minus 3.9, which is $12.05. And since it says 1p, I know that stands for one full pizza. I answered the question. So there is the solution to this, $12.05. Okay, again, recap. I want variables to match, then I want them to be opposites, and then I add or subtract down, get my answer, and if I need to figure out the other one, plug it back in. We're getting close. Write a linear function that represents the data. Okay, Tanya is making da-da-da. So here's what you do for a linear function. There's a couple things you can do, but what I recommend, there's this button here that says Stat. And we're going to edit our own list. We're going to make our own table. If there's anything in yours, you can go to the top and press Clear. Okay, it's got to be clear. Press Enter, and it's gone. Go to the top, L1, press Clear, Enter, gone. And I'm going to fill in what my table says off to the side. Again, this is under the Stat button. Don't be concerned if it drops a 0. That says 7.50. This is 7.5. They're the same. Okay. Now that that's filled in, it says write a linear function. So here's what you'll do. You go back to Stat, and we're going to calculate our function. It's a linear function, so you're going to go to linear regression, not quadratic, not cubic, not quartic, and so on. Linear regression, the first one, number 4. L1, were those your x values? And the answer is yes. L2, yeah. You don't have to worry about the rest of this for this problem, so you can press Enter all the way down, and you're going to end up with this page. I'm going to write down exactly what I see. Y equals, whoops. Y equals ax plus b. A is 0.75, b is 4.5, r squared is 1, and r is 1. We don't need r squared, okay? And you might not see r on your calculator. We'll have to get together and talk about how to turn that on. A quick lesson with that is if you go to Mode, and then you go down to where it says Diagnostics, Stat Diagnostics, it should be on all the time, okay? All the time. So here's the answer. Write a linear function f of x. So they don't want y, they want f of x instead. And it's going to be equal to a times x. A is 0.75 times x plus b plus 4.5. Explain what the slope and y-intercept mean. The slope, you're looking for something that says each or per. It says Tanya is making homemade greeting cards. The data represents the amount she spends in dollars. So this is amount. And x is the number of cards she makes. So if you remember, slope was y2 minus y1 over x2 minus x1. So it's the y's over the x's, dollars per card. So our slope is 75 cents per card. And our y-intercept is $4.50. This is the initial cost before cards are even made. So use the word initial when you're trying to identify the y-intercept. It's often referring to something that exists, a cost or something that exists before the problem even began. So in this case, we had a cost to probably even start the business. Okay, 2 more questions. Alex launched a ball into the air. Height of the ball represented is t equals 0 to 5. So if I want this to be 0 to 5, then I need to calculate how to break this up nicely. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 boxes. I've got 5 jumps to make. 20 divided by 5 means that each t value is going to show up every 4 boxes. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4, 1, 2, 3, 4, 5. Okay. And I'm going to plug this into the calculator because I think every graph should be accompanied by a table of values that the calculator provides for you. Notice I'm using x when I'm putting it in the calculator because the calculator recognizes x on the screen, not t. And I'm going to figure out my table of values for 0, 1, 2, 3, 4, 5. Those are the biggest numbers that I'm concerned about. At 0, it's 5. At 1, it's 37. At 2, 53. Then 53. Then 37. Then 5 again. Okay? Now I'm going to go up to 53 on this scale. If there's 20 of them divided by 53, I'm sorry, if I'm trying to do, let's see, 53 boxes over a span of 20, or think of it this way. If it went by tens, like 10, 20, 30, 40, 50, I would be short, so maybe I can go every 3. At 0, it's 5, so that's going to be right in the middle, and so is 5. At 1, it's 37, so here's 30. This would be 33, this would be 36, so 37 is right about here, so is 4. At 2, it's 53, so here's 50. 53 would be right about here. Same with 3. Now something to keep in mind when you have a parabola, again I know it's a parabola because that's going to be squared. They don't just go up and then flatten. So there's got to be a higher point somewhere in between, directly in between 2.5. So here's what I need to do. What happens when I plug in 2.5? That's negative 8 times 2.5 squared plus 40 times 2.5 plus 5. And calculate that. Negative 8, 2.5 squared. Oops, that didn't seem right. Plus 40 times 2.5 plus 5. And I get 55. That means at 2.5, I'm going to hit a high point of 55, which should be right in between. Now I can curve my graph. Remember, these are soft U's. Don't make straight segments. State the coordinates of the vertex. The vertex is the turning point. That's the one we just figured out. So the vertex coordinates are 2.5, that's the middle, and we went as high as 55. That means at 2.5 seconds, the ball reached 55 feet. Okay, this says units. It doesn't say what it is, so I'm going to take off the and write units. Okay? Last question. Ian is borrowing $1,000 from his parents to buy a notebook computer. He plans to pay them back at a rate. Rate are slopes. 60 per month. He's borrowing $600 from his parents to purchase, so $600 is the initial amount. Here's your y-intercept. Here's your slope. So y-intercept is used for B. He plans to pay his parents back at a rate of $20 per month. That's another rate, so it's another slope. Write an equation that could be used to determine how many months the boys will owe the same amount. Okay, so Ian, let's see. Ian is going to be equal to $1,000, but because he's paying it back, it's going to decrease at a rate of 60 per month. Ken borrowed $600 and he's paying $20 per month. Now it says write an equation. That means one equation where they will be the same. Okay, so they want to know when does 1,000 minus 60 per month equal 600 minus 20 per month. Okay, there's one equation. Determine algebraically and state in how many months the two boys will owe the same amount. So now we're actually going to solve it. I'm going to start with my variable on the right. I always start with my variable on the right if I have one. Then I subtract 1,000. And I end up with negative 40n equaling negative 400. Divide both sides by negative 40, and I get 10 months. Okay. Ian claims that he will have his loan paid off 6 months after he and Ken owe the same amount. Determine and say if he's correct. So 6 months after this would be 16 months. Ian's expecting to owe nothing at that point. So what would happen if I took 1,000 and I subtracted 60 for 16 months? If I took 1,000 and I subtracted 60 for 16 months, I would end up with $40. That's a remaining balance. So would it be paid off? And the answer is no. He still owes $40. He would need one more month to figure that out. Okay? And there is January part 2, 3, and 4.